Good morning, children. Today I am back with you all with the new exercise 2.4 of chapter Polynomials, which we have already started. So we are going to start with the very first question. Children, you can see there is a question written in front of you. We are being told that we have to use the identities to find the product of the given questions. You can see that this is the A part, B, and so on. We have to find the product of the given question, but we have to use the identities. Now, if you will see the very first question, A part, it is given in the form of, if you remember in the last video, I have explained you the different identities. There was one identity which is x plus A and x plus B. So if you will see this question, this is also in the form of x plus A, where A is 4 and x plus b, where b is 10. So if you remember, what is the answer, what is the solution, what is the identity, this will come out to be x squared plus a plus b bracket close x plus product of both the constants, which are a and b. So we are going to use this identity in the very first question, where a is 4 and b is 10. So applying this identity, what we will have in the answer, I will do the square of the first term. If you will see in both the brackets, the first term is same, so it will be x square plus, what I have to do in the bracket, I am going to add both the constants. My constants in the question are 4 and 10. So 4 plus 10 bracket close into x, the first term, plus a and b, means the product of both the constants, 4 into 10. So let's solve it. We will get it here, x square plus 4 plus 10 is 14, x plus, let's find out the product of 4 tens are 40. So this is the answer in which we have used this given identity. Let's look for the second question, x plus 8 in the first bracket and in the second bracket x minus 10. So observing the B part, you can also see that this question is also in the form of the same identity, x plus a. This is our first bracket where a is 8 and x plus b. So this is x plus b, where b will be in the form of minus 10. So again, we are going to use the same identity. So let's do it. Square of the first term, which is x square plus a plus b, means adding the constants. A is 8 plus b. What is my b here? B is minus 10 and plus minus will give us minus. So it will be minus 10 here. Bracket close, x plus, now we will do the product of the both the constants, which are 8 and minus 10. So let's solve it further. We will have here x square 8 minus 10, as minus is in the front of the bigger number, so it will be minus of 2 and we have to do subtraction here because plus minus minus. So it will be minus 2 into x, and let's do the product of both the constants, 8 and 10. 8 tens are 80, but it will be minus 80 because plus minus minus. So this is the answer of the B part using the same identity in the second question also. So let's move further with the C part. Here also, if you will see the question carefully, it is 3x in the first, and in the second bracket also it's 3x. So it's also using the same identity where A is 4 and B is again in the form of negative form minus 5. And our first term is 3x and 3x. So applying the same identity, what we will have here, we are going to do the square of the first term, but here the first term is 3x. So it will be 3x square plus a plus b. What is my a? 4. And what is my b? Minus. So it will be minus of 5. And what is my x term here? My x term is 3x. So this is 3x Now, product of both the constants, which are 4 and minus 5. So let's solve it further. 3x whole square will give us 9x square. So this, let's solve it. 4 minus 5 plus minus means we are going to do minus, which will give us 1. And why we will write here minus 1x or simply minus x? Because negative sign is in the front of a bigger number. So this is minus x. And but here we have one more. We forgot that we have 3x. So it will be minus 3x. Let's move it further. Plus 4 5s are 20, but this is of minus. So again plus minus minus. So let me change the sign here. It should be minus of 20 here. Yes. So this will give us minus 20. So this is the answer of the C part, applying the same identity in all the three A, B and C parts. What is our identity that we used in the three parts? Let me just revise with you once again, which says x plus A into x plus B is equals to x square plus A plus B of x plus AB. So this was all about the three parts. Let's move to the part D. What our part B says, now you see this carefully. The first term is y square plus 3 by 2 and the second y square minus 3 by 2. So both the terms are same in both the brackets. There is only change in the sign. So if you remember the identity which I explained you in the previous video, there was one identity which says that whenever you have x minus y and x plus y. So you can see that both the terms are same. There is only change in the sign. This identity will give us x square minus y square. So we are having this question in the same form, in this identity, where our x is our first term, which is y square, and our second term, which is y, is 3 by 2. So using this identity, what we will have, as we are given here x plus y, you can write it any way. Plus 1 will come in the front or at the back. Both ways it's correct because they are in the form of multiplication. They are in the separate brackets. So it's x plus y and x minus y. So which will give us x square. So we are going to do the square of the first term. Our first term is y square here. So what I will do? I will first write y square and I will be doing the square of my first term. This is our identity same. Minus the second term, which is y. In the question, the y is 3 by 2. So I will do the square of my second term also. So y square of square will give us 2 2s are 4. So it will be y4 minus. So let's do the square of the second term. 3 3s are 9 by 2 2s are 4. So this is the answer of the D part. Here we have used another different identity. I'm repeating it, which says x minus y into x plus y will give us x square minus y square. Here x is the first term and y is the second term. So using this identity, what we did the square of the first term minus square of the second term. So let's move further to the E part. Now, look at this question. This question is again the same one as we did the D part. We are having the same type of question, which is in the form of x minus y, where x is 3 here. If you will see the question, x is 3, the first term, and y is the second term, 2x. So x minus y into x plus y, which our identity is saying that it will come out to be the square of the first term minus the square of the second term. So let's apply this identity in this question also. Our first term x is 3 here. So we'll be doing 3 square minus the square of the second term. Here the second term is 2x. So 2x square. So solving it further, we will have here 9 minus 2x square means 2 2s are 4 and x square. So this is the answer of the E part. So in the first question where we have 5 parts, in the first 3 parts we use a separate identity, and in part D and E we use this another type of identity. I hope the first question is clear. So let's move further with question number 2 of the same exercise. Now this question is different, but yes, we will be using identity in this question also. But first we have to look for that which identity is best suitable for the given question. Now, what is the question? We have been told that we have to evaluate the products without multiplying directly. In the smaller classes, what we used to do, we used to multiply it directly like this: 103 multiplied by 107. So we used to get the answer. But here it has been told in the question that we have to solve it without multiplying it directly. So we have to see that we have to make it in such a way so that we can use a identity here also. So looking at the first number, which is 103. So children, if you will see this question carefully, we can break the first number. We can write 103 as 100 plus 3. So and 107, we can write it as 100 plus 7. So we are going to do like this. So the first will be 100 plus 3. Why I'm breaking it? Just to look for identity into 100 plus 7. So I have broken by both the numbers. Now see this question very carefully. The first term is same in both, and the second term in both the brackets are different. So if you will see that this question is in the form of x plus a into x plus b. So where first term is the x, which is both in both the brackets, and second term in both the brackets are same, which are the constants 3 and 7. So let's recall this identity that we used in the previous question also. What we used to get in this identity, which says x square plus a plus b of x plus product of ab. So applying this identity, let's solve this question. First, we are going to do the square of the first term, which is 100. So this will be of square of 100 plus, then it says we have to do a plus b. What is a? 3. And what is b? 7. So 3 plus 7 of x. X is 100. So we are not going to write here x because x is 100 in the given question. Plus, let's do the product of a and b. A is 3 and b is 7. So let's solve it further. 100 square means 100 into 100, which will give us 10,000. Plus, now 3 plus 7 will give us 10, and 10 into 100 will give us 1,000. So this will be 1,000 plus. Now 3 sevens are 21. So we have solved this step. Now we just need to add this. These three terms we are going to add it, and we will have the answer 11021. So this way we will solve the question. So we just applied this identity. We just converted our question in such a way so that we can use it identity. I hope the question is clear. Let's move further. Second part. Now see, in the second part, we are given in the form of 90s. Now you will see the question carefully. Both the numbers are in the form of 90. Now you can break the question in two ways. You can make it as 90 plus 5 and 90 plus 6 also. Or you can do like 100 minus 5 and 100 minus 4. Both ways it's correct. But children, you have to always prefer that way so that our calculation should also be easy. So for this reason, we are going to break it into the form of 100 minus 5 here and 100 minus 4 here. Why? Because if we are going to break it as 90 plus 5 and 90 plus 6, that way also will get the same answer, but it will be giving us a little lengthy calculation. So to make our calculation easy and to save our time, we are going to do it in the form of 100. So the first one will be broken in the form of 100 minus 5. And the second one will be in the form of 100 minus 4. So this way I have written my both the numbers in the form of hundreds. Now look at this question very carefully. It is again in the same identity, x plus a and x plus b, where in this question a is minus 5 and b is minus 4. Yes, both are in the negative form. So let's apply the identity in this question also. The first is saying the square of the first term. So it will be 100 square plus a plus b, means I am going to add both the numbers. Minus 5 is my first number, and then plus b. Plus b. B is my minus 4. So plus minus minus, it will be minus 4 of x, where x is my 100, plus product of both the terms. My terms are minus 5 and minus 4. So this is how we applied the identity here. Now let's solve it. 100 square means we will have here 100 into 100, 10,000. So minus 5 and minus 9, minus minus plus, but the sign will be negative as minus is there in the front of a bigger number. But we will do addition of both the numbers, minus 5, minus 4, minus 9. And minus 9 into 100 will give us minus 9. So this is actually addition sign. My pen is little slippery today, so just correcting it. So this is the negative sign. Now let's do the product of both the terms, minus 5 into minus 4. Now we know that 5 4s are 20, but what sign will come here? Minus minus in the product sign will give us plus, but outside there is one more sign. Then plus and minus will give us minus of 20. So this is how we solve this way. Now let's move further. Oh, children, I did one mistake here. It's not minus, actually it's plus here. By mistake, when I was just rubbing it, I made it into minus. Actually, it's plus here. If you will see, the identity says we have to write plus here. So this will also be, because minus 5 into minus 4, 5 4s are 20, minus minus plus, and outside also it's plus. So it will be plus of 20. So solving it, when you will add 10,000 plus 20, you will have 10,020, and then you subtract 900 from it, and you will have 9120 as the answer. So in both the questions, we have applied the same identity. So let's move to the last part of the same question. So we are given one number in the form of 104, which is in the form of 100 something. But the second number is given in the form of 90s. So what we will do in this case, the 101 will be written as 100 plus 4. If you remember in the previous question, I told you prefer to write it in the form of 100 because it will make our calculation easy. And the second one is given in the form of 90 something. We can write it at 90 plus 6, but we will not do it because we want, in the first term, we want it 100. We want the same first term in both the brackets so that we can apply the identity. So it means it will be written as 100 minus 4. So let's look at these two brackets, and if you will observe these two brackets, they are in the form of x plus y. We have used this identity in the previous question, and x minus y. This identity is saying that we should have here x square minus y square. So we are going to do the square of the first term and the square of the second term. So there is an only change that we will have a negative sign when we are going to solve the identity. So let's solve it. It is 100 square, the square of the first term, minus the square of the second term, which is 4. So this is 10,000. 4 4s are 16. So subtract it and you will have the answer 9984. So this is a third part of question 2. So in both the parts that we did today, we have used the different identities. Basically, we used two identities in both the questions. One identity is this one which we used, x plus y into x minus y, which gives us x square minus y square. And the other identity that we used in few questions is this one, x plus a into x plus b will give us x square plus a plus b of x plus ab. I hope this video will explain you both the questions of exercise 2.4. So I'll meet you again with the next question in my next video. Thank you, children. God bless you all.